Hi there. Thanks for joining us on Space Nuts, a Q&A edition. This is where the audience sends questions in. Sometimes they send us homework. Sometimes they send us in a request. We've got a bit of all that today. And we're going to hear about the full moon effects or not, curved space, light speed in terms of detecting somebody who's in a spacecraft doing light speed. Can we do that? Could we? And are we living in a simulation of the universe? Those questions will be answered, possibly today, on this edition of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And joining us to sort all of that out, maybe not, it's Professor Fred Watson, astronomer at large. Hello, Fred.
Hello, Andrew. Here I am, back again.
Good to see you. Good to see you. Yes, yes, indeed. I suppose we should start with not so much a question, but a request for clarification on something that was spoken about in an earlier episode. And this comes from Peter, and he's in the Adelaide Hills down in South Australia. Hi, Space Nuts. Love your show, but I'm afraid I have to call out some pseudoscience that Heidi propagated in the most recent episode about the full moon, with surprisingly no pushback from Fred. You're both in trouble, both of you. Some animals are affected by the cycles of the moon, and there is huge anecdotal evidence by police, nurses, etc., about increased activity during a full moon. But science relies on data, not anecdotes, and several large studies and meta-analyses have shown that the full moon effect is not real. The data of these organisations shows no increased activity during a full moon. I think this should be corrected on air so as not to mislead your, well, he says viewers, listeners, both. We've got both. There are already enough mythical beliefs out there. Thanks, Peter from Adelaide Hills. Before you respond to that, Fred, I might say, and this is anecdotal, that when I started in radio, I did 5 years of midnight to dawns, working from midnight till 5, midnight till 6, 1 till 5, all sorts of weird overnight hours. And I can tell you without a shadow of a doubt, if there was a full moon, it got really weird. I got the strangest phone calls from the strangest people, and it happened without fail. And I mean, it didn't just happen on full moons, but it happened a lot more. Whenever there was going to be a full moon and I was on air, I'd go, oh, no, not tonight, please. But it's true. I don't know why, but it just, and it's not me perceiving that because you never think about it any other night, but it just happened much more significantly, I suppose, with strange phone calls and weirdisms. But it's anecdotal, yes, that bit.
Yeah, that's right. And Peter's right, absolutely right, that the statistics don't bear it out. The reason that didn't crop up in the particular show was, if I remember rightly, it was right at the end. And Heidi was sort of finishing on a high note. It might even have been at the end of Heidi's last show. And I didn't really want to say, well, you're wrong there, because not that I'd ever say that, of course. But yes, I know that the statistics don't bear it out. I suspect what increases perhaps the visibility of things like that is just the fact that you can see more.
Yeah.
The fact that the sky is bright during full moon. And so we do get this impression that all hell breaks loose. I know you talk to nurses, they always say the same thing. And yeah, teachers say that kids are all stroppy at full moon. That might be because they don't sleep as well. And maybe that's part of the problem, that people, if they sleep with their curtains open or they don't have proper blackout curtains, they're going to get a poor night's sleep because it's so bright out there. The full moon
it could be as simple as that, Fred. Could absolutely be as simple as that. Having experienced, and you have done this too, 24-hour daylight,
yeah,
I can understand how it would interfere with your normal sleep patterns. In fact, while we were on the ship recently up in the Arctic Circle in the northern summer, people did complain about poor sleep simply because they had window cabins and it was bright all the time, 24 hours a day. Not glowingly bright. I mean, it got down to sort of twilight levels at some stages, but it was never dark. Mm-hmm. And that, a few of us who weren't used to it certainly felt the effect. We had an interior cabin by choice because we knew we'd be up there for this, so we didn't have any trouble sleeping because we blacked out. But if you had a window cabin or a balcony cabin or something, it was a different story. But I also wonder if it's just in my experience with overnight radio and the weird phone calls I used to get on full moons, if it was an effect of people just thinking, oh, it's a full moon, let's just be galoots and carry on like pork chops,
Maybe. Let's pretend that we're all going lunatics.
Stark raving.
That's where the word comes from.
That's true. Yes.
Yeah.
Although that suggests that this is not a new phenomenon either.
Exactly. That's right.
So yes, you'd need a lot of evidence to back up claims that the moon does cause certain ill effects in the human psyche, but studies prove otherwise. But he's right about the animals. I mean, just about everything on Earth's affected by the moon in some way or another.
Humans are too. Not denying that. There's monthly cycles in human physiology. So
absolutely. So yes, debunked, Peter.
So well spotted, though, Peter.
Yes.
It's good to have an opportunity to talk about it again.
For sure. Thanks, Peter. Hope you're well. When we were in Adelaide Hills, which would have been in June, a couple of weeks after we got on board the ship, the weather was dreadful. And we went up to Mount Lofty to see the beautiful view. We saw a fence and then you couldn't see anything beyond it because it was so cloudy and windy and wet.
Oh, dear.
And actually, I should point out, when we got back on the ship, we couldn't leave that night because the seas were so bad. So they kept us in Adelaide overnight. And we left the next morning and the seas were pretty rough, just trying to get up around the West Australian coast from Adelaide. And as we were about to make the turn north, we got hit by a massive squall. And Judy and I were at lunch and it hit the ship like something hit the ship and knocked us over on a 7-degree tilt.
Wow.
And we couldn't straighten up. Took a few hours to straighten the ship up. They couldn't get the ballast right, and things went flying everywhere. We were having lunch and glasses and cutlery and plates and food and wine and the beer went everywhere. It happened over the entire ship. I don't know how much stuff they lost that got smashed, but it was a heck of a bang. So yes, I'm going to have to go back to Adelaide and see it in nice weather. That's the point I was trying to make. Thanks, Peter. Let's go to our next question. Hey, Andrew and Fred, love the show. Been listening for years. I've had this idea bouncing around for a while about how space is curved and what that might mean. I haven't found much that explains why it's a bad idea, so I figured I'd ask you. If matter curves space-time in a negative way and the universe is overall flat, wouldn't that mean the voids have to curve space-time in a positive way to balance it out? And if that's true, could the curvature of void space act like a kind of pressure that helps hold galaxies together, maybe even removing the need for dark matter? Also, if time flows differently in the void because of the curvature, could that help explain things like the Hubble tension? Curious to hear why this doesn't work. Rob from the Central Coast. I'm assuming Central Coast, New South Wales, because there's a Central Coast in Queensland as well. My only question about his question is he talks about the universe being flat. I would have suggested it's actually a sphere, wouldn't you say?
So yeah, flatness is it is a misleading term because it refers to the fact that Euclidean geometry works. In other words, angles of a triangle add up to 180 degrees and all of that stuff. Parallel lines never meet.
Yeah.
That's what the term flat means. And curvature is yes, the opposite of flatness on large scales. But yes, exactly as Rob, isn't it? Exactly as Rob says, the universe is thought to be very nearly flat. And so there is curvature that's put into it by matter, exactly as he says, but it does sort of even out. And his comment about if there's positive gravity in the voids, could that explain the phenomenon of dark matter clumping around galaxies? The trouble is there aren't really any galaxies in the voids, which is why they're called voids, because there are no galaxies there. They're pretty empty. But I don't think, even if you stuck a galaxy in one of these voids, I don't think the curvature of the space will be enough to mimic the phenomena of dark matter. I think it will be too weak.
Yeah. Lots of people are trying to disprove dark matter, aren't they?
I mean, it's great that they are. One of them's a Space Nuts listener, Peter Verweyen. I don't know whether he's still doing his PhD on MOND, modified Newtonian dynamics, but he certainly was last time we spoke.
Yeah. Hopefully they'll figure it out one day, because it is one of the great mysteries. Dark matter, dark energy, as we talked about in the last episode, wormholes, multiple universe theory. There's quite a few big issues, if you like, being debated.
Yep.
And theories being put forward, but no answers yet. Although the science seems to very heavily favour the existence and effect of dark matter.
It does. It's the simplest explanation. It's Occam's razor. You apply the simplest explanation to something. And yeah, dark matter fits that bill. And if you get rid of it, if you build a theory that says that Newtonian dynamics doesn't work at very low accelerations, which is what modified Newtonian dynamics is about, then it upsets other measurements that you can make. Yes, it means you don't have to have something extra to hold galaxies together, but you have problems with clusters of galaxies and things of that sort. So, and dark matter seems to fit the bill. The annoying thing is we've no idea what it is and we can't find it.
Yes. In fact, finding anything of that nature is very, very difficult. The Large Hadron Collider's had a few specks of success.
But nothing like what was hoped for with the upgrade to 14 tera electron volts, which is what happened a decade or so ago, more than a decade now. Yeah.
Yeah. Maybe they need to put some new batteries in it or something.
There are plans for something like new batteries, but it's a little bit more far-reaching than that. So the Large Hadron Collider is a 27-kilometre underground tunnel, circular. They want to increase the energy of it in order to find these heavier particles, which might include dark matter particles. But to do that, you've got to make the Large Hadron Collider bigger. And so what they're talking about now is the Future Circular Collider, which has a tunnel length of 100 kilometres.
Whoa.
Not 27, but 100. And that's not funded. It's still a gleam in people's eyes. But if it was funded today and was going to be built, it would come online in 2070, by which time Space Nuts might actually be defunct by then. I can kind of imagine that.
Although
Jonty might keep it going.
Yeah, he may. Nothing ever gets taken off the internet, so it'll all still be there, I think, somewhere. Yes. Okay, so the answer is probably not.
That's it. That's the correct answer.
Probably not. All right. Good thinking though, Rob. Thanks for getting in touch with us. Yeah. Great to hear from you. This is Space Nuts Q&A edition with Andrew Dunkley and Professor Fred Watson.
Roger, you're loud and clear here also.
Space Nuts.
Now, our next question is also a text question, and it comes from Ian Anderson. My question is, if beings have developed vessels that travel at light speed, would we be able to detect them with current technology? Could human eyes detect an object travelling at light speed? Yeah, interesting question, Ian.
Well, the only things that travel at light speed are photons.
Yes.
Because it's impossible for anything else to reach light speed. Because
in a vacuum.
Yes, that was correct. Yeah. Yes, all right, let's clarify that too, in a vacuum. That's good. 300,000 kilometers per second. Relativity says that in order to accelerate something with mass to the speed of light, you need to input infinite energy. And that's a bit of a drawback, really, to travel at light speed. So photons do travel at light speed. We don't actually see photons as they whiz by, but we see their effect when they hit a surface, whether it's the retina of an eye or the wall behind the screen I'm looking at here now, or the wall behind me. That's when you see the photons, because they basically radiate the light.
Yeah.
Back to you. If you had some object traveling at very nearly the speed of light, invented by some alien beings of superb intelligence, you would be able to see it, but you'd have to be in certain places because the light would radiate out from it in a kind of almost like a shockwave. So you would only see it if you looked in certain directions. It's a phenomenon called aberration. It's the way a beam of light changes direction because of the velocity of the moving object.
Sounds similar to when a fighter jet hits the speed of sound. People that they've actually taken a few photographs of aircraft at that precise moment, and it actually causes condensation in some cases around the aircraft, like they're bursting out of a cloud, but they actually created the cloud.
Yeah,
and the Big Bang, and the Big Bang that created the Big Bang as well. I grew up near an RAAF base. And we quite often used to hear
sonic booms.
Until they banned it.
That's right. They were double, weren't they? Didn't you get two bangs?
Yes.
Yeah, that's what I thought. Indeed, I used to live near an RAF base when I was a student at St Andrews. There's the Luchas Royal Air Force Base right next door. They used to scramble their jets nearly every day because of Russian bombers intercepting airspace. So not much has changed, has it, in the world of Russian aircraft probing the defences of the Western Alliance?
Well, these days around Australia, it's Chinese ships. Yeah. So seen a few of those. But we used to see all sorts of weird and wonderful planes flying over the Macchi trainers. The Mirage jets were in action when I was a kid. We used to see the Bell Huey helicopters. They even had Wirraways and Wingeals back then, the old prop aircraft.
Right.
But this was at Williamtown Air Force Base, which was only 15 minutes drive away from where we lived. So, but there were jets up there all the time. Always
there would be,
flying.
And there still are actually. Williamtown's still pretty active.
Well, of course, right next door to it's Newcastle International Airport.
That's right. Yeah.
So it's a pretty busy place these days.
It is. Yeah.
Did we finish with Ian's question? No, you probably wouldn't, would you? If there was a spacecraft capable of light speed.
Yes, well, you wouldn't if it was capable of light speed, but if it was just under the speed of light and you were looking in the right direction, then you might see it. Yeah.
Yeah, okay.
It will be very heavily blue shifted as well, the radiation.
Okay. There's a telltale sign.
There you go. Yeah.
We'll keep an eye out for them.
Look for blue lights in the street, and if you see them, pull over.
Quickly.
Yeah.
Thanks, Ian. Good to hear from you. Our final question's an audio question coming from Martin.
Hello, Space Nuts. Martin Berman Gorvine here. Writer extraordinaire in many genres, with a cosmic philosophical question. But first, I want to say, Andrew, I forgive you for not looking me up when you were in the Washington, D.C. area, because I realized that if we had gotten together, the field of dad jokes would have been so dense that nothing could have escaped it, not even groans. So my question for today is, what if the universe were indeed a simulation? Is there any hard proof we could have that such a thing were true. And I have to say, I don't believe it for a moment. I'm with Dr. Samuel Johnson on this one, who refuted Bishop Berkeley's idealism by kicking a pebble. And the only proof I could think of that the universe would be a simulation would be if we discovered that the redshift of an extremely distant galaxy were the square root of a negative number. Get it? Then the redshift would be imaginary, and hence the whole universe would be imaginary, which makes about as much sense as anything in this whole question. Can't wait for the answer. Berman Gorvine, over and out. Out.
I think he answered it himself, didn't he? And Martin, yes, I'm sorry we didn't get together, but my time in Washington was very, very limited, and we were on an organised tour, and we all had to be in certain places at certain times. So I didn't have a minute up my sleeve. So that's. But I did think of you while I was there. I hope you detected that in our simulation universe style of life.
Martin might have had 40 people turning up on his doorstep if you'd come with it.
Might have too. Are we living in a simulation? Look, I think there are those that argue that our universe is a manifestation of our minds. That's been put forward. But then, yes, simulation theories, that's sort of doing the rounds fairly regularly these days too.
Look, it is an interesting one. How you prove that we're not in a simulation. The only line of argument that I've heard, and it's quite an old one, is that if we discovered that space-time was quantized, so it was moved in jerks rather than smoothly, that might suggest that we're in a digital simulation. If you've got space-time being represented by something that's got discrete steps in it rather than being completely smooth. And I'm thinking now about the way we record music digitally, where you chop up the waveform into these tiny digital steps, and you wouldn't know that you were listening to a digital sound made up of little jumps in time. So if the universe was discovered to be like a digital waveform, then maybe it will be a simulation. But it's still not definite proof. I think the only way we'd really know is if this big face appeared in the sky and they said, you're being simulated, you're not real.
Wouldn't feel good.
It wouldn't feel good, no. It would not be a feel-good moment.
I'd have a bit of a problem with that. But it's certainly something that's been portrayed in various forms of sci-fi, the simulated universe.
Yeah.
But, I just don't understand how it could exist. There's just too much going on. Like, if it's a simulation, it's got a damn good computer program running it.
Yeah, that's right. I mean, in a sense, there's an equivalent problem which is being, I guess, looked at by the world's great theoretical physicists who ask the question, is there a deeper underlying reality that underpins both quantum mechanics on one hand and relativity on the other, and sort of essentially brings them together? And if there is a deeper reality, what does it mean for our existence? And you're quite right. Consciousness has been. Just excuse me 1 minute. I'll just call them back. Consciousness has been regarded as maybe a part and parcel of what the universe does and the way it behaves. So that's a very intriguing puzzler. If you need consciousness in order for the universe to exist, what kind of a universe are we living in?
Yeah, that's one of the things I think's been talked about fairly heavily in recent years. That one really is a mind blower, though, that consciousness created the universe. Again, very hard to believe, and it would. I don't know how it would work.
No, that's right. I mean, whose consciousness are we talking about here?
Well, that's right.
God's or ours or
yeah, or a collective.
Yeah, collective. Yeah. Interesting
all
stuff.
All very interesting and all very weird, but always good to talk about. But thank you, Martin, for asking and answering your own question and allowing us to discuss it. It was a good one. Keep them coming. If you've got some questions for us, please send them in. We encourage you to do that. Don't forget to tell us who you are and where you're from. And you can do that through our website, spacenutspodcast.com or spacenuts.io, and you just click on the little tab up the top that says AMA. We did, I think, look at getting that changed to, voice messages and things, but I don't think this interface allows it. But yeah, you can fill in the blanks there as well. If you've got a device with a microphone, it's pretty easy to send us a voice message or a voice question. Fred, we're all done. Thanks for helping out today with all of that.
It's a pleasure. I'm glad to be of assistance.
We'll see you next week.
Sounds like it, yeah. See you
later this week, as the case may be.
Yes.
Thanks, Fred. Professor Fred Watson, astronomer at large, and thanks to Hugh in the studio, who couldn't be with us today because he's a simulation. And from me, Andrew Dunkley, catch you next time. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.